Hello, welcome everybody. This is Dr. Song. I like chemistry for many years. First, what is chemistry? Let me show you an example.
Your lessons go for auto sequence start.
And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T-minus 20 seconds. T-minus 15 seconds. The sound suppression water system has been activated.
And your lessons go for main engine start.
We have a go for main engine start. Engine start. 2, 1. Booster ignition and liftoff of Discovery.
What you see in the video is an example of chemistry. Actually, it's the reaction to produce H2O. This is another example. This structure is for the red color. This one is the most famous antibiotic, penicillin. It's saved 200 million lives since 1920. Determine the structure of penicillin and study the mechanism, why and how this structure kills bacteria. It's also chemistry. This is the reaction. Some of the reaction inside of the cell is the result of reaction result the life. Look at this part. You may be familiar with the glucose. Glucose is a part of the food. We eat the glucose, which react inside of a cell with oxygen. That's why we breathe. It produces CO2 and water and energy. The energy is for activity of life. The glucose is synthesized from CO2 and water and energy. This energy is the sunlight. So this process is called photosynthesis. So this reaction is so important. The reverse reaction is called respiration. This is also chemistry. Look at the plant, how beautiful. It's made from alloy, plastic, rubber, cellulose, and paint. So chemistry with the math, with the physics, all together make the plant. This is chemistry. Chemistry, from the few examples, you may realize, so chemistry is everything. Let me give you more detail. We start from a cup of water. If we magnify 100 million times, you can see the small particle inside of the water. This small particle is called molecule. Inside of a molecule is called atom. This is the oxygen, this is the hydrogen. inside of the oxygen atom, there are even small particles. This is the nucleus. The outside is the electron. So proton and neutron make a nucleus. The electron move around. It's make together. They make an atom. So the whole thing, this one, is atom. Atom make a molecule. Molecule make everything. So chemistry study atoms, molecule, and reactions. What is atom? So hydrogen and oxygen are atoms. So molecule is two or more atoms together. That's called molecule. So hydrogen, because there are two atoms, it's a molecule. O2 is a molecule. H2 is 3, it's a molecule. Some molecule contains thousands of atoms. Reaction. As we see in the video, the hydrogen react with the oxygen produce H2O. This is a reaction. Since everything is made from 3 particles, look here. 3 particles, proton, electron, neutron, they make an atom. Atom make a molecule. So chemistry starts from these 3 particles. First, proton. Proton, the mass is 1 mu. Neutron is 1. Electron is small. Proton has a positive charge. Neutron has no charge. Electron is a negative charge. So proton, neutron, electron, only 3 particles make up everything. Now, you may wonder, what is mu? The definition of mu, which is the carbon atom divided by 12. This is the definition of mu, which is 1 mu is 1.66 times -24 grams. If we write in decimal, 1 mu equals this one. You can see how small of the proton, neutron, and electron. Or you can write another form. So 1 mu equals this gram. Or you can write 1 gram. If you divide by this number, we get this one. So 1 gram is 6 times 10 to 23 mu. From this information, just to let you know, proton, neutron, electron are very small, so atoms are very small. Molecules are also very, very small. We cannot imagine how small, but we still know the structure. That's amazing. This is an example of oxygen. Oxygen has 8 protons, 8 electrons, and 8 neutrons. How do we know? Oxygen has 8 protons. Now, you just remember oxygen has 8. How do you know? You just remember that. I will show you how to know more. You may heard atom, element. So what's the difference between atom and element. All the atoms with the same number of protons is called element. For example, CO2. How many atoms? 3 atoms. But how many elements? Only 2. Let's look at glucose. How many atoms? 6, 12, 6 is 24. How many elements? Only 3. It's carbon, hydrogen, oxygen. So that's the difference for element and atom. How many elements so far we have discovered or created? 118. You should remember this number. 118 elements that combine to form how many molecules? You already know molecule H2O, that's a molecule. CO2, carbon dioxide, is a molecule. C6, H12, O6, this glucose molecule. You already know 3. So total how many molecules we have discovered? 120 million. That's lots. 120 different molecules we have discovered or created. How many reactions? Today in the video, I already show you. So hydrogen react with oxygen produce H2O. This is a reaction. But so far, how many reactions we have discovered or created? How many? 130 million. Is that a lot? Now, chemistry is everything. Chemistry study atom, molecule, reaction. There are 120 million molecules. There are 130 million reactions. That's a lot. How to learn chemistry? Is chemistry difficult? Well, it depends. Periodic table is the key to the door of chemistry. If we know the right method, the chemistry is not so difficult. So periodic table, what's this? As we said, there are 118 elements. 118 elements. So periodic table contains the information for the 118 elements. This is the most important table in nature science. This is also another version of periodic table. If you search online, you can find many different periodic tables. You need to download at least 2 periodic tables for chemistry. What is the information the periodic table can tell you? All the periodic table can tell you atomic number is that one. All the periodic table can tell you the symbol of element, that one. And atomic mass, which is in mu, that one. Some periodic table tell you the name, the carbon, but some periodic table no name. So you need to, if there is no name, they may have some other information, but you at least you need to have a table with the name. Atomic number, as we said, this is the atomic number. What's the meaning? Atomic number tell you is the number of proton, is the number of electron, is the number of nuclear charge. So chemistry starts from the three particles: proton, neutron, electron. They make atom. They make a 22118. Then they make a 120 million molecule. The 120 molecule undergo reaction. So 130 million reaction. So this is the type of reaction. That's the basic overview of chemistry. Now let we do one question together. This is a 100 grams of water. How many H2O? How many H2O inside of the bottle? First, you need to find H2O. This hydrogen is 1. Oxygen, the mass is 18. 16. So together, one H2O, one molecule is 18 mu. One molecule is 18 mu. Mu is how many grams? Do you still remember? It's 6 times negative 24 grams. That's one molecule. It's converted to gram. How many molecules you write X? Equal how much? Equal 500 grams. Then you do the math. You can solve X. X is about 25. It's a big number, 25. Now, this is how to do the question. So you can start with 100 grams, no, 500 grams. 1 gram is 6 times 10 to 23 mu, as I just showed you. 1 water molecule is 18 mu. You can see this one is the conversion from gram to mu. That one is mu converted to molecule. So this is called conversion factor. You write it in the way, this gram you can cancel. This mu you can cancel. So you got 1.67 times 10 to 25 molecule. That's a lot molecule. So 500 grams of water equal this many water. This also tells you how small of the molecule. For comparison, the population of the world is only 8 times the 9, but a bottle of molecule is 10 to 25. There's some conversion you need to remember. Again, 1 mu is 1.6 negative 24. Or you can write the fraction form. Yes. So you can write 1 over this one, they are the same. Or you put this one on this side. We get 1 gram equals 6 times 10 to 23 mu. This writing, of course, you don't like to write that one. So we use scientific notation to write the large number, to write the small number. In the future, if possible, we use scientific notation to present the number. So what's the definition? So scientific notation, only one integer. For example, if 1, 2, 2, 3, 4, you write 1.2234 times 10 to 4. You can see there is only one integer. So for this page, you need to remember the definition between gram and mu. And you need to know we use scientific notation, and you need to know the definition. In the periodic table, you may notice there is something called IUPAC. IUPAC. It's the international authoritative organization in chemistry. It decides everything about the chemistry. For example, why carbon is called carbon? Why carbon is 12.011? So this organization published is for the world of chemistry. So it's good to know. You already know the meaning, this atomic number, this symbol, this name, this mass. Okay, the most important is the atomic number, which is the number of proton, number of electron, and number of charge. Again. Now, after we know the information of atom from periodic table, you may wonder how to understand the chemical reaction. So atomic number determine electron number. Actually, they are equal. Is the electron number determine chemical reaction? You look at periodic table, you find how many electrons. From how many electrons, we can predict the chemical reaction. How to do that? For example, if we mix the sodium and chlorine together, what happens? If we put sodium into water, what happens? Can we predict this one from the periodic table? Yes, we can.
sodium metal is heated until it melts and just begins to burn. Then it is immersed into the yellow-green chlorine gas. The sodium begins to burn in chlorine with an intense yellow flame. It produces the white smoke of sodium chloride. We are observing the exothermic reaction of sodium metal with chlorine gas, producing the white solid sodium chloride.
Can you see? This is the product of sodium with chlorine. Before reaction is a gas, is a metal. Now is a salt. Before reaction, the sodium, the chlorine is very poison, don't touch. But the sodium chloride is safe, we eat every day. Let me show you if we put sodium into water, what happens. Wow. You know, the water, usually it can stop the fire. But if you put sodium into water, it produces the fire. What's the reaction? Now, let me show you what's the reaction between sodium and chlorine. We start from periodic table. So this information is from periodic table. So now, can you see the 11? This is the atomic number. That means sodium has 11 electrons. The 11 electron is moving in the 3 energy level. The energy level 1, there are 2. Energy level 2, there are 8. Energy level 3, there is 1 electron. You may say, oh, we can find the number of electrons from periodic table, but how do you use this one? How do we know that one? Well, in some periodic table, it's tell you, look at this. It's 2, 8, 1. That's the electron configuration, which tell you is 2, 8, 1. The 2, 8, 1. Now, electron move around the nucleus at a different energy level. So 1, 2, 3. 1, 2, 3. That's number 1. Number 2, electron in highest energy level. It's level 1, the level 2, this is level 3. So this is the highest energy level. The number in the outside or in the highest energy level is called valence electron. This is a very, very important word. Actually, is the valence electron determine the reaction. Then sodium. Usually, we pay attention for an atom to see how many valence electrons. That one determines the reaction. How? Keep going, I'll show you. But from here, electrons move at different energy level. The outside, that one is called valence electron. Sodium has how many valence electrons? It's 1. That's sodium. After we know sodium, we need to know the chlorine. Then we can predict the reaction. Chlorine is 17. You can look at that one in the periodic table. Look at this one. It's the electron configuration. So 2, energy level 1 is 2. Energy level 2 is 8. You can see it's always 2, 8, and something else. Then it's 7. The outside is 7. So chlorine has 7 valence electrons. So when you look at the periodic table, we pay attention to how many valence electrons. That's more important than how many total electrons. Before we can predict the reaction, we need to know in chemistry, there is a famous rule. It's called octet rule. Absolutely, you need to know that. So atoms tend to have 8 valence electrons. 8 is an important number in chemistry because of the octet rule. Why? Because if an atom has 8 valence electrons, it has lost energy and it becomes stable. For example, chlorine is 2, 8, 7. It's not 8. Then we can predict. So atom want to have 8, but this only 7. What you can say? Oh, it want to be 8, but it only have 7. So it want to gain electron. So that we can predict the behavior of chlorine will gain electron. Let me look at this one. Sodium is 2, 8, 1. How to be 8? Is get 7, that's take too much energy. If it's lose 1 electron, it's become that one. So if this one is gone, the outside is become valence electron. It's 8. It's stable. Now, when sodium meet chlorine in the video, sodium is this is one is 1. This is 7. They both want to be 8. The most save energy way, so this one move to here. Then it's become 2, 8. So this is octet. This one become 8. This is octet. That's why you need to remember the octet for chemistry. Sodium lose electron to be octet, but this because it's lose electron is positive. Chlorine gain electron to be octet. Gain electron is become negative. Because the electron is negative, you must know that. That's the first step. The electron in the video, you can see that one. Actually, is a electron is transfer from sodium to the chlorine. That's the process. Now, before we finish the sodium chloride story, I have to tell you a most important law is called Coulomb law. It's the most important law, number one, in chemistry. What the law say? If positive and negative charge, they attract. If positive and positive and negative, they repel. So different charge attract. Same charge repel. Absolutely, this is important. This is why they form molecule. This is the fundamental reason. This is also the first page tell you the direction. Let's say positive and negative, they attract. That's part one of the Coulomb law. Part two, the force. How much? Of course, this determines the molecular property. How much? This we can calculate. It depends on the charge. It also depends on the distance. The product of the charge, you divide by distance square, you times a constant. This is the fundamental constant, which is the force between two charges. Coulomb law. Again, if you remember one formula in chemistry, that's the one. It's number one law in chemistry. Here, sodium lose electron become positive. Chlorine gain electron become negative. So positive attract negative according to Coulomb law. They attract each other. They form sodium chloride. So in sodium chloride, sodium is positive, chlorine is negative. They are stable. So when sodium positive attract chlorine to form sodium chloride. This attraction is ionic bond. When they form bond from the free atom to form molecule, forming bond always release energy. For this one, it release 800 kilojoule. This number is called heat of reaction. It's negative. Why? Because it's a release energy. It's lose energy. If you lose some money, your money is decrease. Decrease, the change is negative. So that one is called heat of reaction. Remember again, forming bond always release energy. If a reaction release energy, we say it's called exothermic. If it's exothermic, the product has lower energy and are more stable. Another reaction may be absorb energy. If it's absorb energy, we say it's endothermic. Exo means out. This means out. Endo means in. This give energy. This take energy. If it's take energy, the product has high energy. If it's high energy, it's less stable. So you need to remember these words in this page. So endothermic absorb energy. So exothermic release energy. I just show you, the sodium react with chlorine according to the octet rule. So this one, electron transfer to here, then both become octet. You understand that? Now, if chlorine meet chlorine, what happens? This chlorine is 7. They said, oh, hello, can you give me an electron? I want to be 8. So this chlorine said, I need an electron also. How can I give you? Finally, they share electron. They find the way. This one is 7. Can you see? 7. This is symbol. That one is 7. They cannot lose, cannot gain, because they are equal. So finally, they cooperate. They share the electron. Really? Yes. They really share. Then they put this one, they put an electron in the middle. They put an electron in the middle. Then these two belong to both. Now that one belongs to both. Then this become 8 electron. How about that one? It's 8 electron. So both are octet. Both are happy. So 2 chlorine atoms share electron. It's not lose, not gain. They share. When they share, both win to be octet. When they share electron, in terms of energy, they release energy to form CO2. If they release energy, they become more stable. Low energy is stable. So when the chlorine meet chlorine, they not lose, not gain, they share electron to be octet. Octet rule, okay, again. Look at the energy changing. These 2 atoms separate. Now they share electron like this one. The energy decrease. This one has low energy. Low energy is more stable. It's lost how many? It's lost 239 energy. So what's the heat of reaction? Again, if it's lose energy, you must write negative. So the heat of reaction is negative 239. If in other words, if you see the delta H is negative, you know it's a release energy. So share electron release energy. Release energy become low energy. When it's low energy, is more stable. Look at this. This is the energy. Here, is 2 chlorine, 1 here. Another one is here. There are 5 ways. The energy is here, is 0, for example, whatever. Now, when they two closer, so this one is closer. When they're closer enough, they share electron. Then the energy decrease. Can you see? Oh, that means at this distance, the share electron, they have lost energy. So this one is the energy before sharing here. So that one is the energy after sharing. Then the difference is here. This difference is called bond energy. If bond energy is great, we say the bond is stronger. Because it's low energy, if you want to break them, you need to provide energy. Here is the bond energy. That means, chlorine react with chlorine, they form the covalent bond. They release 239 energy. You say, oh, how about this one? Hydrogen react with oxygen. They form this bond. They also share electron. Oh, this is the table. It's bond energy. Let me find which one has the strongest bond. HF. Can you see? It's the highest number. That means HF bond is the most strong for single bond. If you look at other bond, CO bond is 1000. So this is the strongest bond. So this is the bond energy. Actually, you can find the value in the reference table. When you see the bond energy, you can know how stable of the bond, how stable of the molecule. Also, oxygen. Oxygen has, if you look at the periodic table, it's 6 valence electron. Yeah, you look at the table, that tell you that one. That means oxygen has 6 valence electron. But it wants to be octet. Then it can react with hydrogen. It can react with another hydrogen. Then you see what happened? Let me see we write the hydrogen. This one, we write the red one. We write the red one, A, here. Then this is hydrogen. This is hydrogen. Look, this oxygen become 8. That's why it's H2O. It's not H3. Because it's already 6. It's only need 2 to be 8. So that's why oxygen can combine with 2 hydrogen. If you want to know how stable, you look at the OH bond. OH bond here is 400. So it's pretty large. It's strong. Now, let me tell you another thing. If you use hydrogen, you react with nitrogen. So this time, it's not H2 nitrogen. No, it's H3. Why? Look at this. So nitrogen is 2, 5. So 1, 2, 3. It has 5 valence electrons. So you can see it needs 3. It's not need 2. That's not enough. It's not need 4. That's too much. It's only need 3. 1 here, here. So 5 need 3 to be 8. That's why they react with 3 hydrogen. They form that one. Oh, they share electron. They share electron. They share electron. Octet rule. You can see if you understand the octet rule, and you understand, you can find the valence electron in the table. You can make many molecules become simpler. So that's why NH3 is not NH2. Atom combine to form molecule by chemical bond. I already tell you that 3 chemical bond. I already tell you 2. So ionic is sodium, there is 1. So chlorine is 7. So this one transfer to here. Why? Because it's become octet. It's become octet. It's a 2, 8, 1. So it's a loose one. So that one, so 2, 8, 7. Once the electron transfer to here, it's become sodium, become chlorine. So both are octet. So this become 2, 8. This become 2, 8, 8. Both reach octet. Then positive, negative attract. They become sodium chloride. That's called ionic bond. If you put a chlorine and chlorine, this is 7, this is 7. Now want to lose, they share. Wow, they share electron. Share how many? Share 1. Why? Because it's already 7. So now this one become 8. So this become 8. So valence electron plus octet rule, we can explain most of the molecule. So this 2, 90% of 120 million molecule is formed by ionic bond and covalent bond. That 10% is metallic bond. So that's for today. I will see you next time.